This video is about using the properties of isosceles triangles to solve for missing variables and to use properties of equilateral triangles to solve for missing values. So first we're going to look at the two triangles here, isosceles triangles and equilateral triangles. So isosceles triangles, remember, are triangles with at least two congruent sides. Those two congruent sides are called the legs. So in this case, RD and ED would be the legs. The base is the non-congruent side, which would be RE. Our vertex angle is the angle across from the base. So in this case, it'd be the vertex angle at the top. And the base angles are the two angles that are opposite to the legs, so R and E. Remember though that the base might not always be on the side, so we could have on the bottom we could have the base on the side and the two legs off to the side if we turn the triangle. In an isosceles triangle, if two sides of the triangle are congruent, then the base angles are congruent, and the converse then is the reverse of that. So if two angles in the triangle are congruent, then the two opposite sides, which are the legs, are also congruent. In an equilateral triangle, this is a triangle that has three congruent sides. All equilateral triangles are equiangular because if all three sides are congruent, the opposite sides would be congruent. So we'd have three congruent angles. 180 divided by 3 would get us 60 degrees for all of those. So let's use these properties to solve using isosceles and equilateral triangles. So number one, we want to draw an isosceles triangle with a base length of 4 and legs of 6. The base angles are 46 and the vertex angle is 48. So all we're doing here is we're drawing a picture and putting things in the correct spot. So I have my isosceles triangle with two congruent legs. Those each have a length of 6 and 6. The base is 4. The base angles, which are the angles formed by a leg and the base, are both 46. Remember that we're going to have two of those that are congruent. And our vertex angle, which is formed by the two legs across from the base, is 88 degrees. In number 2, the base angle of an isosceles triangle is 64. What is the vertex angle? So in an isosceles triangle, if one base angle is 64, so is the other. Remember that in all triangles, they add up to 180 degrees. So we can do 180 minus the two angles we know. So 180 minus 64 minus 64. So we get that the vertex angle is 52 degrees. Solve for the variables in each problem. So in number 3, if we look at the triangle at 28 degrees, we notice that is an isosceles triangle because two legs are congruent, which means x, and the other angle that's not filled in is also x because these would be our base angles. So in order to get x, we can take 180 minus the vertex angle and then divide by 2 so we evenly split between those two angles. So 180 minus 28 is 152. Divide by 2 gets us 76. So we have 76 degrees and 76 degrees. Now, we need another angle in the other triangle. So what we can do is use this straight line, and we can do 180 minus 76 to get us 104 degrees. Then to get y, we know that that's another isosceles triangle. So y and this other angle is also going to be y. So y is going to equal 180 minus 104 divided by 2, which is going to get us 38 degrees. In number 4, we want to start with a triangle that has a number in it. So we're going to start with the triangle that has the 65 degrees, which is an isosceles triangle. So if we have 65 degrees, our other angle is also going to be 65 degrees. To get the last angle in that triangle, we can do 180 minus 65 minus 65, which is going to be 50 degrees. This looks like a bow tie, which means that we have vertical angles. So we can use our vertical angles to get an angle in the second triangle. So if the one vertical angle is 50, the other angle is also 50 degrees. This second triangle is an isosceles triangle. So 50 and x need to be congruent because they are base angles of the triangle. So x is going to be 50 degrees. In number 5, in order to solve for x, we know it's isosceles triangle, so our base angles are congruent, so we really have two x's here. So x is going to equal 180 minus 100 divided by 2. So 180 minus 100 is 80, divided by 2 would get us 40 degrees. So these angles are both 40 degrees. In number 6, we are switching gears because all 3 sides are marked congruent, which means that if it's an equilateral triangle, it is also equiangular. So all of our angles are going to be 60 degrees. So we have 14x minus 22 is equal to 60. We can add 22 to both sides. So we get 14x equals 82. We can divide by 14. So we get x is 5.86. In number 7, we have 2 legs that are congruent of both 21, which means that we have an isosceles triangle. So these base angles are going to be congruent. So to solve for x, we can set them equal. 3x plus 24 is equal to 8x minus 41. So as we solve, we get 24 equals 5x minus 41. Add 41 to both sides. 65 equals 5x. When we divide, x is 13. In number 8, we also have an isosceles triangle. So we have the vertex angle, which is 5x minus 6. We have one base angle that's 4x plus 15. So our other base angle is also 4x plus 15. So we're not going to set them equal to each other because they're the same angle. But we know all of the angles in a triangle equal 180. So we can add this all together. 4x plus 15 plus 4x plus 15 plus 5x minus 6 equals 180. So as we combine like terms here, we get 13x plus 24 is equal to 180. We can subtract 24 on both sides. 13x equals 156. When we divide by 13, x is 12. Pause the video and try the U-Try problems on your own. Check your answers with the U-Try problems. If you need more time, pause the video. So the first half of the notes, we looked at problems dealing with the angles. Now we're going to look at problems dealing with the sides. So in number 1, we have an equilateral triangle because all 3 sides are marked congruent. So they're all going to have the same measure. We know that one side is 28. So all of the sides of this triangle are going to be 28. So to solve for x and y, we can create 2 equations. 3x plus 7 equals 28. Solve for x, so we get 3x equals 21. Divide x is 7. We also have 4y minus 16 equals 28. We can add 16 to both sides. 4y equals 44. Divide by 4, so y is 11. In number 2, solve for x and y. So again, this is an equilateral triangle, but this time we don't have a value because all of the sides have a variable on them. So we're going to create 2 equations here. So I'm going to pick any 2 sides. So first I'm going to pick 6x plus y equals 2y plus 8. I can subtract the 2y over, so x minus y equals 6x minus y equals 8. Then I can set up a second equation. So I'm going to have 10x minus 4 is equal to 2y plus 8. So I can subtract the 2y over and add 4 to both sides. So I get 10x minus 2y is equal to 12. Now that I have my 2 equations, 6x minus y equals 8. And 10x minus 2y equals 12. I can eliminate a variable, so I'm going to multiply the first equation by negative 2. So I get negative 12x plus 2y equals negative 16. 10x minus 2y equals 12. So when we add straight down, we get negative 2x equals negative 4. Divide x is 2. Then we can substitute back into one of those equations. So 6 times 2 minus y equals 8. 12 minus y equals 8. We can subtract 12 from both sides. Negative y equals negative 4. When we divide, y is 4. So we get 2, 4. In number 3, we have 2 base angles that are congruent. So the sides that are opposite of those base angles are going to be the congruent legs in an isosceles triangle. So we are going to have 3x plus 15 is equal to 6x plus 3. So as we solve, we get 15 equals 3x plus 3. We can subtract 3 on both sides. 12 equals 3x. When we divide, x is 4. In number 4, similar idea. We have our base angles that are congruent, so our legs are also congruent. So 9x minus 10 equals 7x minus 2. So as we solve, we get 2x minus 10 equals negative 2. We can add 10 to both sides. 2x equals 8. Divide. So x is 4. In number 4, we need to create a picture. So ABC is an isosceles triangle. So I'm going to draw an isosceles triangle with base AB. So that means the bottom side's AB in this case, and C is on the top. So if I label, I have 5x plus 13 for AC, 7x minus 1 for BC, and 9x minus 7 for AB. So we want to solve for x and find the perimeter of ABC. So we know the legs are congruent. 5x plus 13 is equal to 7x minus 1. So as we solve, 13 equals 2x minus 1. Add 1 to both sides, 14 equals 2x. When we divide, x is 7. Then it wants us to find the perimeter, so we can substitute 7 into each of our sides. So 7 times 7 minus 1 is 48. 5 times 7 plus 13 is 48. And 9 times 7 minus 7 is 56. So we're going to add all three sides together to get our perimeter. So we have 48 plus 56. We get a perimeter of 152. In number 5, DEF is an equilateral triangle, which means all the sides are congruent, with a perimeter of 12x minus 6. One side is 13x plus, or 3x plus 16, so that means all the sides are going to be 3x plus 16. So now we can solve for x. So 3 times 3x plus 16 is equal to 12x minus 6. So 9x plus 36 equals 12x minus 6. We can subtract 9x from both sides, so 36 equals 3x minus 6. We can add 6 on both sides, 42 equals 3x. When we divide, x is 14. So then to find the length of the side, we can take one of those sides, 3x plus 16, and substitute. So 3 times 14 plus 16 will get us a length of 70. Our ST has a perimeter of 120. Solve for x, then classify the triangle by its side. So we don't have any markings to know if it's isosceles or equilateral, but we have all three sides and the perimeter. So we can add them all together. 11x minus 4 plus 9x plus 4 plus 12x minus 8 is equal to 120. When we combine like terms, we get 32x minus 8 equals 120. We can add 8 to both sides. So we get 32x equals 128. When we divide, x is 4. So if we substitute 4 in, 11 times 4 minus 4 is 40. 9 times 4 plus 4 is 40. And 12 times 4 minus 8 is 40. So to get so now that we have all of our sides, they're all 40 in this case. So a triangle with 4 or 3 equal sides is equilateral. Pause the video and try the try problems on your own. Check your answers, and if you need more time, pause the video.